Can't afterglow, sweating velvet, I lose control. Your heat's the only thing I know. Finger like a ghost perfume, still naked in an empty room. Your voice a drug I cannot feel. Each note a mark I can't conceal. Sweat and velvet, say it slow. Whispers wrapped in afterglow. Sweat and velvet, I lose control. Your heat's the only thing I know. Slow. Touch me slow in the dark, I breathe. Your name still dripping off my teeth. Still can't static in my bed. You haunt the back room of my head. Can't run, can't sleep. Your touch buried deep, still I fall. Touch me slow, say slow. Whispers wrapped in afterglow. Touch me slow, I lose control. Your heat's the only thing I know. Linger like a ghost perfume, still naked in an empty room. Your voice a drug I can't undo. Each note a mark I can't conceal. Midnight Gleam City.
Good morning, everyone. Uh, I am Vishwanath Ammo. I am from JNARDDC Nagpur. We are the co-organizers of the event. So there was some kind of situation there. The panel discussion has got delayed, and now there is since there are very less audience, so we have decided to call it off. And at least the members who have come for the, we want to acknowledge their kind valuable time which we have they have spared for us. So at least I will introduce the members. The member is one of the senior member is Mr. Vikram Junjunwala. He is the chairman and managing director of Century Extrusions Private Limited. And he's a commerce graduate from St. Xavier's College, Kolkata, and he is well-known personality in the extrusion industry. And essentially, extrusions is also one of the major players of extrusions, and they are also supplying some of the extruded products in defense industry also. Another member is Mr. K. Srinivas. He is executive director of Vikas Altech Private Limited. It is automobile manufacture different extrusion profiles they are supplying to the automobile industry in India and abroad. And also I welcome Mr. Dushyant Gupta. He is from Vedanta. He is most responsible for the billet quality and other aspects in the Vedanta Limited, and also Mr. Sahu. He is Big Mint. He is from Big Mint, and there is a launch of this book from the um, Big Mint Association. Uh, Mr. Sahu will be taking over, and then he will briefly introduce about his what are the contents of this book and other details.
I yeah yeah. First of all, I mean, thank you, ALEMAI, for giving this opportunity. To be honest, if I introduce with this knowledge report, unfortunately, I think the audience is discouraging, but still, we have a good time with the panelists, and the topic is also very relevant in terms of quality, if I say. Uh, so today we are going to discuss about the quality aspects of aluminum extrusion segment. And to be honest, it is not a quality is nowadays. It is not only uh, deciding factor for the prices, but nowadays it has become more aligned towards the branding of your branding of the product. It is also a more competitive age in today's era of quality, especially when India is going from a middle income company to the higher income. The quality emphasis is going very high. So in this session, I think we will explore billet chemistry, homogenization, filtration, and standards, along with the policy and technology which is being, which are shaping actually the quality parameters of aluminum extrusion industry. Uh, not to stress this session long, I will request our fellow panelists to have a keynote speech, especially on the quality front. Just one minute speech, sir. I mean, the development and the things which are happening in the market. If you allow, I think we can stretch the session also. But just to start with, I will request Vikramji to start with. If you want to share your journey, especially the quality side, since you have been in this industry for a long time, especially in India. We started in last 20 years, if you see how the quality parameters of the product of extruded product in India has shaped up uh, since then, and where we are, where we stand in globally. Yeah.
Good morning, everyone. Aluminium extrusions quality is extremely important in today's world. We are moving towards globalization and we need to be very focused on quality. As of now, extrusion was not being considered as a quality product either by the buyer or by the manufacturer. But now the time has changed and we need to focus on quality. And quality can only be derived by the right equipment, right raw material, right process control, and right methodology to produce extrusions. Today we have world-class quality of billets available in India. The equipments are also available worldwide. So getting quality product and getting our footprints worldwide is very important on the quality. Today the manufacturing sector in India is growing in all the sectors like automotive, engineering, defense, aerospace, architectural, and all of these companies or the ultimate buyers are looking for quality product, which we can achieve by making quality within ourselves in our plant and making India Atmanirbhar. I would also request everyone to focus on quality of billets, homo billets, grain structure, process control, quenching, finish cut, and then packing. So we are responsible for every step of the product during manufacturing to achieve the quality. Thank you.
Thank you, Mr. Junjunwala, for summarizing the industry. I'll request now Mr. Srinivas, from OEM point of view. Uh, do you find, I mean, what are your views for the quality parameters of the industry uh, and the extrusion industry's capability currently here in India? Where do you see the biggest gap? I mean, chemistry control, dimensional accuracy, or surface finish accuracy?
Morning. So, from a end user point of view, what I can say is there is a need, rather than talking about the gaps, I would say that there is a need to closely work with the between the extruders and the billet makers, and of course the end users. We are seeing there's a lot of subsequent processing that happens on the extrusions. There is welding operations, there are brazing operations, there are vacuum brazing operations, there are subsequent lot of critical operations that the extrusion undergoes in the subsequent process of building the end product. And things like what Vikramji mentioned about the homogenization. Homogenization might look like a very simple thing, but it is extremely crucial for the end life of the product. We have experienced failures at an early mileage on the vehicle side because of grain size issues and grain boundary corrosions. So those are the kind of issues that we are seeing. Surface finish, of course, can be immediately detected, but things like grain structure are, you not find that, but then they can surface up as a early mileage failures at the vehicle level. So those are the kind of collaborative work that is needed between the extruders and the end users. That is extremely important. And the second part of it is the chemistry. As the industry is progressing, as we see new technologies coming up on the automobile front, as we see a lot of electrification happening, we are seeing the need for new age alloys, alloys which are, in terms of the corrosion life, in terms of the beaten life, the customer demands are increasing. So the need to work on new alloys is very important, and that is where a lot of collaborative work needs to be done, because the new alloys cannot just be done by an extruder. It has to be done in collaboration with the end user and see and test it at different levels and see how we can arrive at the best chemistries. again, as Vikramji mentioned, because as a lot of electrification happening, the opportunities for exports from India is what we are seeing is an immense possibility. There again, the speed of development of futuristic alloys is very important. So these are the things that a lot of collaborative work needs to be done.
Thank you, Mr. Srinivas, for talking about the special alloys which India is, aspiring to produce. Now let's move to the sensor. I mean, you're really representing a big segment, big volume of the industry, and I think Vedanta is also investing a lot in technological front. So especially to drive the quality initiatives, I think there is a primary segment which should be the leader in the industry in terms of the investment, so that the other industry can also follow. But there is a big challenge. I mean, there are a lot of imports are coming, especially in special alloys, APC. Uh, so how do you see the current quality initiatives or the technologies which are present here in India? And what are your views that it will shape up in next 5 years going forward? And will we be able to, offset all the imports, especially the alloys or special alloys, which Mr. Srinivas has mentioned?
Good morning, all. I think we are sitting at a very right juncture to discuss on this particular aspect about imports of extrusions and other things in India. Uh, in this scenario, when government is protecting our industries through Make in India, Atmanirbhar Bharat, there are lots of impetus has gone to develop the Indian industry. So now it's the time industry should evolve and get this opportunity for developing their capability in such a way that, see, why imports are coming in India. Indian market is a big market, and when you leave any opportunity unattended, then only the imports from outside come to India. So presently, the industries in India are now looking for avenues and expanding their capacities to serve the access market which is available in India. So to answer your question, for the next 5 years, there are industries who are aligned towards the growth of Indian sectors. Like if I take the example of extrusion sector, presently it's a total consumption of extrusion in India close to 1 million, and it is going to be 1.5 million in next 5 years time. And if I see the big players like Vedanta, Century, Global, and all, which are actually taking a big role in developing this sector, so they are also expanding more the rate the growth is expected. So uh, import as such not cannot be eliminated by the industries itself. Yes, there are some government advocacy and impetus is required to stop the import. But yes, we are at a very sweet point to explore maximization of the Indian market and stopping the imports. Thank you.
Yeah. So just because of time constraint, I think we will have to just stop this session. Thank you very much for the LMI and especially the esteemed panelists to join this session. We are just going to inaugurate the event report which we prepared for this event from knowledge segment. I think you will be able to find it in LMI website also. So basically, in short, if I say about this report, I think the purpose or the objective of this report was to make all our stakeholders keep informed that what are the general supply demand scenario of India in terms of aluminium, especially in extrusion segment. What are the problems this industry is facing, and where we can have some policy or technological uh, uh, solutions which can be incorporated to have a better sustenance of the industry. So I will request all the panelists to inaugurate this report. Yeah, thank you very much, sir.
Thank you.
Sir, sirs, please wait. We'll have small memento for all the panelists. On behalf of LMI, we want to give small memento to all the panelists. Thank you very much, sir, for your valuable time and then sparing us to attend this panel discussion. Though there are some time constraints and other different difficulties, so you have shown your what can say, you have shown your what you can say, passion to participate in this panel discussion. Thank you, sir. the presentation. Right? We'll start. Just I'll introduce you and then yeah. Yeah. Right? Yeah. It's not just wait. I'll introduce. Can start.
Okay. Now I want to make sure that this doesn't move, doesn't change the. It's,
Just I'll introduce. Yeah.
but let me see if. Okay.
Good morning, everyone. This is the technical session, which is having two presentations. It is the theme of the session is future of extrusion, intelligent press management, and other innovative technologies for the extrusion related. As you know, the press is most important part of the extrusion process. So, what are the technical advancements which are happening in the press design, construction, and other activities? So, we have got two speakers in this session, Mr. Rossano Bano from Prezi Extrusion Group and also Mr. Mohit Agarwal from SMS Group India. So I'll introduce briefly the speaker of this session right now. Mr. Rossano Bono is Technical Sales and India Area Manager for Prezi Extrusion Group. He is from Prezi Extrusion Group and specializing in complete extrusion and he joined the group in 2023 following the incorporation of his own company into Prezi. So he will explain the details, more details about his the specialty of his presses and what are the latest advancements in press technology. And over to you, Mr. Bono.
Thank you. Good morning, everyone. It's a pleasure to be here at the Alumex. I'm as a Rossano Bono from Italy, representing Presezzi Extrusion Group. This is an Italian company located in Milan. Uh, just a second, I put my glasses. Our company has more than 30 years of experience and over 1,200 projects worldwide. Uh, we have offices in Italy, US, Mexico, India, Dubai, and Switzerland. We can design, manufacture, install a complete full extrusion line, gas billet heater, and special treatment furnace, equipment for foundry, melting furnace, homogenized furnace, complete packaging line, automatic storage, and die system. So this is those are the range of product we can supply. Uh, we are also proud to be recognized as one of the leading players in the aluminum extrusion industry, thanks to our continuous innovation and a strong partnership with our client. So this is representing where we are actually a family company owned by Presezzi is the name of the owner of the company that is a president and also sales director. Our company has now more than 300 employees, and this is you can see the distribution of the more than 1,200 projects we have done in during our 30 years of business in the world. Of course, our main market was Europe, but North America, South America, Asia, and now we try to develop our business also in India. going to the point of today that I would like to touch with you is extrusion is a energy intensive process. Optimizing efficiency is not just by saving cost. It's about reducing environmental impact and ensuring long-term competitiveness. At Presezzi, sustainability is not a trend, but is part of our DNA. Every technology we develop has one clear objective: to reduce operational cost while lowering emissions. Here you can see a list of products that we manufacture. We supply complete extrusion line from billet heating system to extrusion presses, cooling system, handling, automation, aging oven, packaging, and storage warehouse system for aluminum profile. But what makes us as a unique is that we are not only a machine supplier. We provide integrated solution tailor-made to customer requirement, and with advanced automation and digital monitoring system. I will enter in a description and give you some more information about our technology, our principal product. We have our gas fired billet heater that is ensure a maximum heat recovery from exhaust gas. So with that, we are able to achieve efficiency up to 78%, and is believe me, is one of the maximum level that we can reach with the gas heating furnace, and with energy consumption that is 169 kilowatt for every ton of aluminium. Then about 10 years ago, more than 10 years ago, we started developing a new system for electrical heating of the billet that we call ZPE. That means zero pollution emission. That is our flagship innovation. That ZPE is a permanent magnet heater for heating the billet. It's a unique technology that achieve energy efficiency up to 82% with extremely high repeatability of the billet temperature. We can guarantee a repeatability of ±3 degrees, and in the core and on the skin of the billet. We guarantee uniformity of the temperature. We can reach a temperature up to 100 degrees per meter, and that is of course very good for guarantee the for the isothermal extrusion to have such a high level of temperature heating. Compared with the traditional electrical heating system for billet that are the induction heater, ZPE offer of course lower energy consumption and less and reduced maintenance, and also the possibility to be powered by renewable electricity, because the advantage that we don't have any we don't need a high frequency. Actually, the system is made with AC motor that are running with a standard 400 volts and 50 hertz. So that is make much easier the connection to any power source. The concept of this system is basically to create current inside the aluminum billet by moving with a motor the permanent magnet elements, poles that we install inside the motor. So rotation of the magnetic field around the billet create such a current that by the Joule effect rise up the temperature and heat up the billet. And that is a guarantee of a uniformity of the temperature from the skin and also inside. So we don't have we can guarantee accuracy and very little difference between the temperature of the skin and the inside. This is a real we take from production measurement of the deviation of the temperature billet to billet. So you can see the repeatability is within plus minus 2.5 degrees. Okay, so this is then if you have a further question about this new technology, we can answer to your question later. Then I would like to speak about one of our main products. Presezzi Group started manufacturing press 30 years ago, and we innovate continuously our press, and we are proud to say that our press integrate PA energy saving system that is based on reduce the energy consumption by using a different hydraulic system, a different concept of modulating the flow of the oil on the press. And that means by lowering the energy consumption of the press up to, in some case, to up to 50%, that lower the operational cost and also and a more sustainable extrusion process. So that is we have about 100 kilowatt hour per ton the consumption of our press. It's a very compact solution, no waste of energy. The pump has a longer life because we are able with this combination of fixed flow pump with a servo motor to switch off the pump when are not needed, and that increase the lifetime of the oil and also of the pump group. Okay, behind the press, we also design fully automated handling, packing, storage, including AGV robotic line. So for I believe that will be in the future the necessary for also for the Indian market to have more automated extrusion line with the possibility to reduce in not now but in the future will be important also for the competitiveness to have to reduce the number of workers and have a guarantee a process with a better repeatability, without failure, without scrap, and the automation is a part of that. Here you can see some of our system for packaging line, for warehouse of profile, warehouse of bundle after powder coating, ready for the dispatch. We have also automatic packaging line with robots that we have already provide to European customers. Together with the new with the design of and innovation, we also anyway, we keep constantly our focus also on the possibility to for offering to the customer upgrade for existing presses where we can re-engineering and by that reducing the energy consumption. So we can offer press revamping with installation of energy saving system on existing press, revamping from a system upgrade to components renewal, PLC and software upgrade to the latest technology, data ingestion, that is a system for control the process by adding sensor that monitor the in real time the machine and store and dedicate the data in a database. So, and then ND testing for the structural assessment of the press and forgings. That is also another service that we can provide for having a guarantee and safety in long term for your equipment. Here you can see also a list of equipment that we can provide for offering a complete cast house, double chamber, single chamber melting furnace, smart camera system to monitoring the aluminum butt inside the melting oven. So fume treatment, refining, and casting loaders. So this is all a part of our product. We also offer together with the extrusion line for the automation software that we call Data Manager Suite that is able to collect data collection, planning of orders, raw material management, production tracking, order management, quality control, process control. So that is also something that you must think about in the next innovation for the Indian extrusion line. And that is a part that we integrate in our offer. Special focus on the service that is mandatory to maintain a relationship with the customer. We can offer a service directly in India with our local specialist from Italy, from USA, from China and Turkey, where we have a different location and basis. Wait a moment. Okay. Just for conclude, I'd like to say that we believe that performance, innovation, and sustainability must go hand to hand. We are the first in our industry also to develop the environmental product declaration for some of our product and proving our commitment to transparency and sustainability, sustainable technology. What I can say that choosing Presetti means have a partner who deliver not just machine, but a complete solution designed for growth, efficiency, and environmental responsibility. So thank you for the attention and looking forward for if you have any question later. And I hope to collaborate to shape the future of extrusion in India together. Thank you.
Thank you very much, Mr. Bono, for your informative presentation. Do we have any questions from the floor for Mr. Bono? Well, Mr. Bono, we would like to just thank you very much for your precious time and sharing this presentation with us. A small vote of thanks from our side. So up next, we have our next speaker from SMS India Group, Mr. Mohit Agarwal, Senior General Manager, Forging Plant. He would be giving his presentation on next generation extrusion processes, innovation and their impact. So I would invite Mr. Agarwal to please come up on stage and share his valuable presentation with us. Thank you.
Hi, good morning, everyone. My name is Mohit Agarwal, and I am from SMS Group. First of all, I would like to thank LMI for giving us this opportunity to present the paper. I would also like to thank all dedicated employees of LMI, the facilitator, my colleagues, and my co-presenters in here, and especially the audience for their time. So, as you know that SMS Group is known for the innovation, and we put continuous effort to invest into the research and development in order to prove that we are continuously working on the technology. We are, one hand, we are talking about the reliability, availability of the equipment. On the other side, we are talking about the efficiency of the equipment with reducing the carbon footprints. And in this regard, today we are going to present you the fifth generation of the extrusion presses, which is under development from SMS side. And this will be another game changer in the market, which I will present into the next slides. So on the right side of this presentation, you can see our next generation presses. And I will tell you how it is different from the older generation presses and why we are calling it a fifth generation press. Okay, so in order to give you a small glance that what we meant by fifth generation. So this extrusion technology is quite old, but the process is, we are just optimizing the process and we are trying to streamline the process further and further in terms of better availability of the equipment and to utilize the equipment by reducing the carbon footprint and energy saving. And in this regard, if you go on the right side, the first technology was the backloading presses, which is called the backloading long stroke presses, in which the container goes on one side, the stem on the other side, as you can see here, and then billet is loaded in between. The total press frame was quite long in this case, and that's why these are called the backloading presses. Then the generation improvised, and we came to know about the second generation of presses, which was called the stem shifting. In stem shifting presses, the stem was shifting to one side, but it is still the backloading presses. But you see the total length of the press frame is much smaller than the older version of the press frame. The third generation presses which still are very popular in the market, is the front loading presses. The advantage of this press is that the billet is loaded from the front side and stem and container goes on another side, and you maintain the center line of the billet along with the entire center line of the extrusion press. So these are the three generations of the extrusion presses which are very popular in the market. In the past, we have worked on the fourth generation presses, and today I'm going to present the fifth generation presses also. But let's talk a little bit about the fourth generation presses from SMS. But before we go to the fourth generation, we thought that, okay, how SMS is unique from rest of the manufacturers. So what we do in our presses, we provide a complete laminated rod structure for the press. And this give you a unmatched lifetime of the press instead of round nut and columns. Yeah, which means that over a period of time, the rods which you are putting into the press to make the frame as one unit, you have to replace that. Also, the thread configuration wherein the thread and the nut is tightened, the area of contact is very less and the notch factor is very high. In order to overcome that problem, SMS has come with a unique design of laminated tie rod, and we put the big keys which gives the bigger surface and the low notch factor. So this is the one of the unique feature with SMS press, which helps you to get a better sustainable press. And we are making these frames from 1970, and more than 600 presses around the globe are into the working. The major part which we want to highlight is that there is no breakage of this frame in last 40-50 years. Yeah. Okay. So another unique feature what SMS offers along with their presses is, I'm again going a little back into the history. So the first generation presses was called X guiding system, where you have a X type of guiding system, and the press complete container and the stem was moving on in and out on this type of system. Later on, the technology evolved itself, and people come with the new technology of phosphorus bronze liners, which has the adjustment. But again, the problem is that after some time, there is a wear out. So in order to accommodate this problem also, SMS is the only company who is providing linear types guiding system. And this linear types guiding system is like, I hope you all have seen the CNC machines. In CNC machines, the movement of the components are very fast. And these are also on the linear bearing, because with the linear bearings, you will get a very good quality preciseness, and the wear factor is equal to 0. So if a proper lubrication has to be done, we can say that this is the part which needs not to be replaced. Okay, so with this technology of linear guides, we can provide you a complete better alignment of the container and the stem, which means that no realignment is required in your press. Then also you can have a reliable front loading press, because in front loading the billet has to be in the center line of the complete press. And if the billet is in the center and it is properly locked by the stem, you will achieve better results while you are doing the extrusion. Along with this, you also have, if you have this kind of system, then you have a very good central alignment with the dies, and you are always try to use the core aluminum from the billet. So these are some of the advantages with our system. There are some more advantages which I tried to put in a nutshell in this slide, but let's talk about few because I only have 20 minutes. Sorry for that. But if you want to know more about SMS presses, we are also having our booth inside the exhibition, and you can come and visit us. So the major advantages with SMS is that we are not using linear guides only into the press, but also into the billet loader, as well as into the side cassette also, so that the complete alignment of the press will remain towards the central line of the press. Then also we would like to talk about the servo billet loader in this case. It's a latest development from our side, which is very energy efficient with the precise control of the press. Along with that, we also have our servo shifting shears. We have our 3-position side table. Uh, we also provide a pressure compensator and high proportionate force into the presses. Also, we have our in-house container designs. Also, we provide a software which is called CATEX. It is called Computer Aided Direct Extrusion. It is an additional software which helps you to achieve isothermal extrusion while you are doing the extrusion. This is the additional software which we can implement along with the machine or separately as well. So we have talked about the 3 generation presses and the advantage of 3rd generation presses which SMS is making in-house. Now we will talk about the 4th generation presses which is called Hybrex. So Hybrex is known as the hybrid extrusion, and this Hybrex has some major advantages. So if you go with the Hybrex machine, as you can see, the design is very compact, and we got the German Design Award for this press in 2017. So the major advantage to go with this model is that you have an energy saving from up to 55%, and you will get 20% higher productivity than the 3rd generation presses. We always like to compare ourselves. Yeah, so if you buy a 3rd generation press from SMS and if you buy a 4th generation of SMS press, you will get 55% better power utilization with the 20% higher production, because the dead cycle time in this presses is even lesser than the 3rd generation presses. Along with that, we have come up with the reduced hydraulic drive. In this case, as you can see, there is no tank on the top. So the tank is on one side, which is very smaller, because we are working on a compensating tank in this technology, which I will present to you in the next slide. And also, if you see that the dead cycle time, we are claiming that we have reduced 2 seconds per cycle. If you see in one cycle, it does not make sense. But if you calculate for an hour or a day, then you will realize that how many minutes you have saved and how much more production you have done in a day. Multiply by 365 days. So these are some of the advantages of 4th generation presses. Okay, so as I explained that we always try to compare within ourselves. Along with our presses, we also have different type of hydraulic solution. So one is the basic conventional drive system solution, which comes with the DOL electrical. And on the right side, you can see the comparison graph. These all 3 technologies are provided by SMS. So basically, the normal presses comes with the conventional. But along with that, we can also provide a SMS eco-hydraulic system on top, which can replace the old generation conventional system. And in this case, this is a live case study for a 28 meganewton press for all 3 types of technology. And in the middle one, you can see this is a conventional press. On the right side, it is the eco-hydraulic solution, which is mentioned at point number 2. And then with the 4th generation presses at point number 3 with the HyberX. So if we can compare the profile size of 1170 billet millimeter with the 22.4 meganewton of force, with the conventional presses, the power consumption is 92.9 tons kilowatt hours per ton, whereas it is around 20% lesser than in the eco model. And if you go with the HyberX, it is around 30% in that model. So this is how we compare internally in-house by ourselves, and we evolve the technology also. And with this, so I think the four generation presses are clear to you guys. But this 4th generation presses with HyberX, with the electrical movement, these presses were a little expensive. And we got a feedback from the market that why don't you think of a combination of hydraulic and mechanical presses? So that's why this is a new development which is going on in SMS. The first prototype is ready, and we are already filed the patent. We are just waiting for the patent to be confirmed, and then these presses will be ready for the market to sell out. So what is the advantage to go with the 5th generation of extrusion presses? Okay, so in the past, we have seen that the press is always moving on the hydraulic system, and we have a hydraulic working in the hot zone also. Either it is a discard shear, or a bolster shear, or even the side cassette. So this is the hot zone wherein always the hot metal or hot aluminium is working. So what we did with the 5th generation presses is we are trying to completely obsolete the hydraulic system in the hot working zone. The entire hydraulic system will be much smaller than the conventional presses. So what it means that your hydraulic consumption of the oil will be reduced by 1/10, let's say. So if you are using a 10,000 liters of oil, With this technology, it will be around 1,500 liter of small tank with two pumps. And then we have a compensating tank, which is on the back side, but there is no oil movement in the hot zone. What we have done in this case is that we have made the complete press hot area as oil-free work area. No oil tank on top, which means you don't need very big wall blocks or the different type of walls like proportional walls or servo walls. There is no requirement of these in this press because the entire system will be managed on floor, which is easy for the maintenance. So this is a live picture from where the idea generated. Actually, this is a live picture on the left hand side wherein there was a oil leakage from one of the cylinder and immediately the entire press was under fire. So from this point, we thought that what we can do to make humans' life better who is operating a press. So that's why we came up with the area and we created a line. After that, there is no movement of oil wherein the hot aluminum metal is working. So we have made a cold area wherein the tanks, the side cylinders, the main tank and a compensating cylinder is working. And in this area, we have come up with the idea of a electrical shear with a pneumatic push off for the discard. And on the bottom also, we are also providing the similar type of technology, but this is optional. And also for the side changing cylinders, that is also as an option. You can go with the hydraulic or you can go with the electrical drives also. So as you can see that the idea is very clear that whenever there is a leak near the hot area, it has a tendency to catch the fire or you have to use a oil which is fire free, but then the cost of investment for the consumer is very high because your OPEX cost will be very high in that case. So that's why we came up with this idea. So you can follow the numbers 1, 2, 3, 4 and 4. So what we meant by this 1, 2, 3 and 4. So the first is electric shear wherein we have completely obsolete the hydraulic cylinder from here and we have come up with the solution of the electric shear. And this electric shear also has a pneumatic cylinder which can be used to discard the push-off. Then we have the pneumatic clamping cylinder in this area for the dies. We are working on that technology right now. As I already explained that we are working on that and the first model of this press is completely ready and we are just waiting for patent to be confirmed so that there is no oil required for the die positioning also. When you take a shear cut, you have to hold the die against the clamping cylinders. So that will also be completely obsolete. Then the third is the pneumatic discard push-off. As I already explained, the push-off of the discard will be from pneumatic. Then the fourth is as an option, but we prefer that when you are investing such kind of equipment, then you can also think of buying a bolster shear, which is operating from the bottom and also the cassette shifter. So this is the mechanism how we are operating the press. I will present this with the video. Go to next slide. Yeah, and then can you please play the video from there? Yeah. Okay, so now you see the configuration of this, that the billet is loaded. We have a compensating tank on the bottom backside. This is used to pre-fill the tank and then the main pressure is coming from this pink pipe and the back oil of this compensating tank is going to tank for cleaning. And when the cycle is finished, the entire oil from this side is coming to the compensating tank. We are storing it for some time before the next cycle starts. And as soon as the next cycle starts, the fresh oil from the pink pipe is coming and the oil in the reservoir at the back is going to the tank for the cleaning and cooling down. So this is how this is. With this technology, we have a very reduced space and the footprint of the machine is also reducing in this. Okay, so together with this, we are also working on making the tank smaller, but the efficiency of the tank has to be that the oil is cooled and there is no turbulence in the oil. And that's why we have divided the entire tank into the three portions. One is our degassing chamber, then second is our suction chamber, and third chamber is our return chamber. Because when the oil is coming back and it is falling down inside the tank, it is creating a lot of turbulence and the bubbles. And that's why we have all these three chambers are connected, but the return chamber is separate by a membrane so that the turbulence and the bubbles of that oil which is falling in will not go to the suction area, and no bubble will travel into the pipe which can cause cavitation later on. So this is the complete thought process behind this, that whenever there is a oil, that oil first of all goes to the degassing chamber. The oil go to the return chamber. From return, it goes to the degassing chamber. And from degassing chamber, it is coming to the suction chamber. And this is how we are working on this technology. So, as I explained you, this generation number 3, generation number 4, and generation number 5, just a very quick glance about the layout. So, if you see the layout of a third generation front loading presses, there is a press area, which is a conventional design. Then on the second side, there is a tank, which is on overhead along with the railings and staircases. And then third is the hydraulic drive system, which is on the back side of the press. To overcome that big space requirement, this was the Hybrids design. Again, the tank from the top is completely obsolete. But if you see the side movements of the press is with the electrical drive. In this area, there is still some oil which is required for the shear. And the tank and the pump station was quite complicated because we are dealing with lot of pumps in this case and also with the servo drives. So this was the fourth generation, and now we will present you the fifth generation presses. So in fifth generation presses, now you will see there is no tank on the top. The hydraulic is much simpler, and the tank unit and the wall stand is also very closer to the press, which can give you a better reliability of the press, and the overall footprint of the extrusion press is reduced. So with this, this is the second last slide in our presentation. As you can see, a normal conventional press with all this piping structure with the valve design and the pump stations looks very complicated. Whereas in a standard 5G press from our side, you can see this looks more easy to handle, and we have a small tank with the compensating tank with the electro servo drives. And I have already explained you the concept. So the first area is to completely working in a oil-free area in this press. Then there is no tank wall blocks on the top, which is very easy for the maintenance. With the reduction and simplification of hydraulic system, it is very easy for the maintenance, and to operate the press is much faster. And then in overall, land is becoming a problem day by day, and it is getting expensive and expensive. So that's why the overall footprint of the press will be around 20-25% than the conventional presses. So with this new HyperX presses or HyperX 5G presses, there are some options which we are providing as an option, that you can also further reduce the oil related equipment in this press by replacing the side cylinders with the electrical drives. Also, you can use the high efficiency of HyperX technologies, which means that the hydraulic system of HyperX can also be put into these kind of presses, and you can enjoy the shortest dead cycle time ever in your presses. Dead cycle time is basically the non-productive time for extrusion press. Uh, so now if, sorry, so as soon as I click the button, now you can see what I meant with the new HyperX. You can obsolete these cylinders from the side, and the movements will be from the electrical drives in this case, which will further reduce the hydraulic oil consumption in the overall press. So in a nutshell, what we want to say, that we already have state-of-the-art SMS standard presses along with the HyperX model. But in combination of these two presses, you can pick and choose and make your own 5G recipe, that whether you want to go for a standard 5G presses with the hydraulic system, or if you want to obsolete the hydraulic system for the side cylinder and container shifting system, you can also choose that as a HyperX 5G. So we provide a complete full flexibility when you are choosing the options. And with this entire system, you can see that there is a complete de-risking of hot zone, which means that the oil and the hot metal is not coming into the contact, less hydraulic complexity, improved footprint, which means that at the overall you will get a very proven and state of the art design from SMS Group. And in terms of dead cycle time and energy saving, the better solution you choose, the less will be the dead cycle time and more will be the energy efficiency. So with this, I end up here with the presentation. Once again, my name is Mohit Agarwal from SMS Group. And if you have any questions, please feel free to ask me. Thank you very much.
Hello. Yeah, thank you very much, Mr. Agarwal, for this very informative presentation. Do we have any questions from the floor for Mr. Agarwal? Pretty technical presentation you had on a very innovative technology here. So any questions? Anybody?
They can come on the
So I think, anyways, SMS Group has got a stall at the exhibition area. So I believe you are there, sir, for the next one more day, yeah,
Right.
last day, yeah.
Yeah.
So if anyone have any query, any question, they can very well get in touch with Mr. Agarwal and get a reasonable answer for that.
Yeah.
Thank you very much for your time, sir,
Thank you.
and for this presentation. Just a small vote of thanks from our side.
Thank you very much.
Well, up next, we have our next speaker for our session, Mr. Gautam Banerjee, who's the technical director with SV Alumex Profile Private Limited. His presentation will be on the role of smart process analysis and control in aluminum extrusion. Before I invite him, I would like to give his a small brief introduction as well. Mr. Banerjee, a veteran technocrat with over 5 decades of global experience in aluminium, steel, and copper extrusion, is renowned for his expertise in metallurgy, extrusion process, and die and machinery design. A 1974 graduate in metallurgical science, he currently serves as a mentor director at SV Aluex Private Limited, guiding its technical team in delivering high quality value added aluminum extrusion for both domestic and international market. I would like to invite Mr. Banerjee on the stage. You're okay with this? This is quite loud. This is the person. You can move. You can move this.
Good afternoon to all. Today we will discuss on total data analysis and process control system in extrusion industry for extrusion industries. So before we start, we all do quality product, but when you do quality product, we just check at the final stage and we determine what is to be sent for packing and what is to be sent for rejection. So instead, the best quality control concept is to control your process at every stages. And for that, we need to ask ourselves every day, what we do? Very simple answer, we do extrusion. Then next question we ask to ourselves, why we do that? Of course, for livelihood. Very simple to answer. Finally, when we ask ourselves how we do, many of us who can't answer how we do, we will discuss how we do. So basically, we have to first know our process. That is what we do. Then we have to identify the critical areas in the process, various stages of our process. That is why we do. And finally, we establish all parameters and check the value of critical areas, and we continue to be abide by that, following that process until and unless we are not finding something more is needed and editing of our process further. So can I go to now when we ask our extrusion people, plant people, what is our yesterday's production? Sometimes they give a good data, sometimes they present a bad data with a lot of excuses. Like, sir, lot of dies failed due to flow defect. Now we must understand why the flow defect and length variation, the flatness and angularity out on active die. Yesterday, the same die ran well. Today, problem. The potential causes can be manual hand polishing of the die to remove the roughness and affected bearing zone. When you do polishing at a particular affected area, we forget about the other areas where we don't do polish. So one area is naturally polished more, another area is either left aside or little less polished. Naturally, the extrusion flow will affect on that. That particular over polished area will exhibit a faster flow. So we have to avoid that. How we will avoid it depends on the infrastructure of that particular extrusion plant. So I'm not going into that part because many an extrusion, what we do, if I suggest that many extrusion plant may not have that, so they will look for other alternatives and all. Next. And relief exit, that is the most important thing to follow. Whatever we see as a joint mark, we call it a joint mark. It is not really a joint mark. Joint is from billet at the back of the die. And that joint, what joint mark we find on the runout, extrusion runout, it is practically, what do we say, it's an oxide deposition or built up just beyond the land area of the dies. And if that land area is not very deep or adequately deep, then what happens? The same oxide rubs on the constant flow of the dye, the product. So we have to be very careful on the relief exit also. Second thing is bearing land area is not blended and very sharp. When we cut a die, usually we try to balance the flow with the resistance. And that resistance we create either from feeding side, feeding pocket side or porthole side, or increasing or decreasing the bearing length. So when we have a very abrupt change of bearing length, that blending is very, very important. We just can't do that. Some area will have 5 mm bearing and the adjoining part will have 2 mm bearing and there is a step. So there will be problem. That creates a flow due to choke and relief creation during the hand polishing. And if it is uniform, at least with the hand polishing also, the polishing will be more or less uniform. Second is, no, I think we went somewhere wrong. C, B, first A, A, prolific one, second one, C. C. Then we found the blistering problem. Blistering problem is very unique. We all know if there is an air interruption or entrapment, there will be blisters. So where from the air comes? That we need to know the potential areas of the air entrapment areas. Center crack of the billet is the main culprit, major culprit. Whenever we cast a billet, we look at the billet surface. Rarely we have a look on the billet core area. Apart from finer grains, the center crack is also important. So we have to check that at least batch-wise, one billet from each batch of casting from the bottom. That if there is a center crack, we should not use that billet. Now, why the cracks are coming? That is a different issue. That subject is not covered here. If anyone interested to know, we will discuss later after this presentation. Then the die pocket remain opens after shearing. When your shear blade condition is not good or there is a gap between your die and shear, more gap, or your die is shaking, or your discard is very, very long or very short, that time some part of the pocket gets opened. And when the next billet try to enter in that gap, there is air entrapment. That also gives you blister problem. Water voids inside the billet. That's a very, very serious problem with all DC casting plants, almost all DC casting plants. The water is coming, still they are continuing with the billet casting. Some bubbles are coming out, but some water gets entrapped in the mushy zone of the billet. Then very less edge clearance between container bore wall and die entry pocket. It is called edge clearance. When the container bore ends and the die pocket still not uh, uh, ended or the die pocket boundary is not very, very, very near to the container bore wall. So that time also air entrapment can occur, particularly at the end of the billet extrusion. Then while that, there is a tendency in our country, all operators, they have a tendency to take a cloth dag and put it on the die to release the metal easily. That is very, very wrong. Let there be metal. the oil is given basically on the shear blade and at the bottom of the die. But if you put it on the entry area, entry pockets and portholes, or near the bridges of the die, then also blister problem comes. Rough surface. This is another area of concern as far as the process rejection is there. Very rough surface, that is again either lower die hardness or worn out bearing. That's a very common cause. But hard and poor malleable metal particles like iron, silicon, manganese, chromium, etc., is either in segregated or undiluted form. If that is there, most of the elements are there either magnetic, directly magnetic, or whenever it forms a combination with rich iron, it becomes magnetic again. So if it is very rich with ferro elements and becomes more magnetic, and we all know when we extrude, there is a serious friction on the die between die and aluminium. So any friction will create static electricity, and it will form a temporary magnet that gets stuck on the die just drop area of the exit. That gives the serious most roughness problem. Oxide rich billet is another contributor. So that is why very thin oxide layer during uh, DC casting with either classical hot top or air slip, whatever it is, the oxide should be very, very thin out on the outside wall so that the oxide part doesn't extrude through the die. Because aluminum oxide is an abrasive by nature, it will create further roughness on the die bearing area. Next comes metal tearing or crocodile cracks. In common language in our country, everybody says shearing, shearing, shearing. Shearing is what no one knows. They think that material is not bonding. Just they will say shearing. Shearing can be there only and only due to incipient crossing beyond the incipient temperature level, which is around 80-85% of metal melting temperature, basic metal melting temperature. Just as what we do, the 70 to 72% of basic melting temperature, if we apply, it goes to the plastic state. But the moment it crosses 80-85%, it reaches to the incipient melting stage and metal becomes a bit brittle. It tends to lose its malleability. Now, there can be a question. If you preheat the billet at 490 or 480 degrees Celsius, then how it becomes more than 560, 565? It is because of the constant friction in the container that graduates the temperature, and the post graduation of the temperature takes place at the bearing point, which what we call as the exit temperature. That exit temperature should not cross 80-82%, 80% at least as for a thumb rule. 82% and 85% is the most precise way. For that, many people use exit temperature indicators with infrared sensors made by some Israel and USA companies, which gives instant temperature control, and your operator will control the speed. But if that is not controlled, you have to leave on operator's mercy. You will first see a couple of feet or couple of meter got damaged, then he will reduce the speed. In turn, the entire length is damaged because half of the part is damaged already. After that, if you reduce the speed also, you regularize speed, still it is gone. So we have to be very, very careful over here, and we have to be really follow the theory of isothermal extrusion. At the end of the billet, we have to give a comment to our press that your speed slows down with the relative pressure reduction of your extrusion. So this is another major problem where we find this process rejection and all. Next. Twist and bend, very simple. Either you don't do proper stretching or your die flow is bad. Sometimes the die is running one side faster, one side slower, and that will surely give you twist and bend problem. And press alignment with reference to the stem versus container is another contributor. If the stem is rubbing to the wall of the container wall, inner wall is getting damaged. That is one issue. Your stem is, your dummy is getting worn out. That is another problem. But the biggest problem is if you have a constant drop at one side of the stem cannot give you a concentric force, concentric pressure to the die for exit. Just what we see every morning, if we press a toothpaste tube from one side, the toothpaste doesn't come out concentrically. It comes out either this way or either this way. So if that happens during extrusion, it becomes very difficult to control that in the stretching. Many people say that we have a detwister in the stretching machine. It's a wrong thing. You just can't use the detwister in a stretching machine with your visual estimation. You cannot do it. So it's a consolation, self-consolation that we have a detwister, let it be there. We compromise with that. Bend and bow across the length. That is again inadequate stretching. But why excessive bends and bow will come? Sometime the die will run upwards. Sometime the die will run downwards. So this way you are giving a formation of a bend or bow by default, and thereafter you are asking your stretching person to do this hard stretching or more stretching. If you do more stretching, that is another problem. If you do less stretching, this will come. With the more stretching, you can have orange peeling problem on the surface. You can have dimensional problem. You can have deflection problem. You can have many more problems. And your stretching lead, receiver and transmission lead, head is the transmitter and tailstock is the receiver. So that receiver and transmission area will be more. So there will be more deflection, longer deflection, and you have to cut out that portion. Recovery will go down. Profile deformation, I have already discussed. Black patches, dents, and damage on the profiles. Most of the time, runout itself is bad. Roller belts are dirty, oily. Somebody uses graphite pieces and they press it. Better correct your die. Don't do like this. These are not the die correctors. Your die correctors, he is employed and he must do it. You must make sure the extrusion comes out absolutely straight from the press mouth. You cannot run it with compromise lifelong. Or next. Now, when you know all these potential causes, so where exactly those are contributing? Because we all know for extrusion, we need billet, we need die, we need extrusion line, and we need process inspection system also. So just divide those into these segments and entrust a person or a team to check separately on these segments so that the final delivery, there will be no checking. There should not be any rejection. You reject here, if you reject billet stage, at least 1 to 3 stage expenses are saved. You can take quick decision. And next time you go back and you take care over there. Adverse effects of variation, potential contribution areas, that is rejection due to non-standard chemistry. Sometimes the chemistry goes out, chalalo, just run it. Rejection due to random blister, we have already discussed. Variation on tensile hardness after age precipitation. This is another area of concern. Most of the places we have double rack aging system in batches. So the entire aging oven has to be it has to be equally balanced thermal management uh, system so that entire furnace we have same temperature or more or less same temperature. If one rack is overloaded and another rack is underloaded, one rack is loaded with a heavier profiles, another rack is loaded with lighter profiles. So one rack weight will be around 2 ton, 3 ton, and another will be 1 ton, 1.5 ton. So there will be variation. So that has to be taken care. At least both the racks should have the same weight so that the temperature distribution and precipitation cycle is not disturbed. A rejection due to random disturbation, oxide-rich metal interference results surface roughness. Oxide-rich, that is another perennial problem in the billet. If your billet is more oxide-rich on the wall side and you are maintaining the same discard length, by default the oxide-rich metal will pass through the die and you will have some oxide patches and all. Then breakdown on billet loader. If your billet is bent, that can seriously uh, uh, cause a major problem in your billet loader and long hitting shear. So there also you have to take care. Once these areas are there, these are all basic areas. There are micro areas also. This is where today we're discussing on macro level to understand. If we take care of these areas, we will definitely get good billets on the extrusion yard. Then comes die. In the die loading abortion is another area of concern. Micro extrusion line, bent, twist, graphite, patches, and all this is another problem. Die breakage, die deflection, very rough surface finish. There's a very funny concept in India. Whenever there is a die breakage, our die experts are saying that steel quality is bad. And if you ask them, what is your die steel quality? No, they will say we must have 50 Rockwell C scale hardness and this nitriding and all. Did you check the hardness? Yes, sir. It was 50. Then how can you say the steel quality is bad? It's a nonsense claim. You must not say. You should investigate what was the exact reason. Yes, die steel quality can be bad due to porosity, but as long as the basic chemistry is matching and other things are matching, like hardness after heat treatment or tempering, there is absolutely no difference between a micro die steel and this. Yes, micro die steel can give you better result because it is well forged and compactness is there. That's a different issue. Similarly, if you ask them, when you are using scrap and recycle to your billets, and you are saying we are delivering the billets as per international standard and very close controlled chemistry, it is as good as a primary metal. There is no debate. So why in the die still there will be a debate? So die deflection, another area, because most of the time we compromise with the same support tool with other dies. Where it is more close support needed, we forget. We just avoid, no, we will not do. This will run, this may run. So this is not correct idea. You have to use proper support tool. Then very rough surface finish. The die bearing, after wire cutting, people forget to polish. Even sometimes they don't polish. They said we give two wire cut, three wire cut. No, you have to do the final polishing and you have to blend the drop area. Bad and stick rich extrusion surface. This was a perennial problem in India since recent past. Everywhere, wherever there is a joint of between two wall, like a T formation, everywhere after anodizing or before anodizing in the mill finish condition, there is a streak mark. So that has to be taken care. Now, how it has to be taken care? Again, point by point, if someone noted, I can answer during our question answer session. And rejection due to underweight and overweight. We don't check. Everybody has got a die history card in their factory, but it is not checked. And sometimes it is not written properly also. Before issuing the die, no one checked that the weight, what was the weight. And if at all they check and report wrongly. After loading, if it is found that it is much overweight, maybe it crossed. Yesterday it was 1 kg, today it is 1.5 kg or 1.1 kg. How it has increased, there is no answer. Maybe the previous weight was written wrong or the weight was correctly mentioned and after that the die corrector, he never referred that this has already reached up to 1.080. If I do the polishing, then 20 gram will increase. He will not bother. He will just polish, send it to the press, and the die loading will be aborted. So these are the things we have to avoid. Extrusion lines, we have already discussed. No explanation is needed over there. Everybody, we have been suffering for this for a long time. Flashing during extrusion and flow defects on dies. Another major area of concern. Whenever there is a flashing, the dead cycle time goes very high. And the die also gets endangered. But still we compromise with the old broken face container or deflected die or hammer marks on the die. Frequent time loss and breakage of stem. Breakage of stem is another area of concern. Whenever there is a breakage of stem, people say the stem steel is bad, the stem is soft, this, that. If it was bad, if it was soft, why you did not check it earlier? Basically, these are align problems, stem breakage. And another problem of stem breakage is jamming of your fixed dummy after the extrusion when it is being taken back by the side cylinder. Then uneven speed of extrusion, oil seal failures, pump failures. This is another area of concern. Uneven speed of extrusion, mainly due to either crispy billets or low temperature billet or very high temperature billet. Very rarely it happens due to air entrapment in the hydraulic system and all. But mostly it is due to billet or oversized dummy. If it is oversized dummy or there is a bellied container, front bore is say 200 millimeter, rear end bore is say 200, 199 millimeter, and at the middle you will find 203 millimeter bore. So there will be uneven speed automatically, because if you do not, either somewhere it will get stuck, the jammy will get stuck, or somewhere it will release and move faster. So next area is failure in mechanical test, surface corrosion, and on extrusion profile. Wherever, if you compromise with the potential contributing areas, you can have this problem, dirty patches, scratches everywhere. Process inspection system, when we go there, we see outright rejection, we see die breakage, mechanical test failure. We were there. Profile deformation. Profile is deformed, it is cut, still it is cut up to the designated length and delivered. No one checked. Wrong quenching media selection, rough, dent and damage extrusion surface, just pack it, load it. So if we compromise all those earlier areas shown in the that cause and effect diagram, we will have this problem every day. That is why it is a must to see. This is a very sample and very small matrix. First, you have to identify your process. If you have a die, before issue, please check these, at least these potential areas. It can be more also. People are there, but they don't check. They directly go for polishing. If it is any of one or either of one is not conforming to your quality standard, please do the correction, go back for checking, and issue for extrusion in the die area. This is called identification of your process and defining your process and identification of your critical areas. Those are the diamond shaped areas or critical areas. These are the correction work plan. What check you have to do before issuing the die, written over there in the earlier back job. Back. Here in the one diamond area, there are 4 checks. There can be more. So just reference of this in the next. When you have a flow defect, please refer the nose, please. And there, if you see flow defect must be due to faster flow or slower flow. So wherever you see there is a slower zone, 3 side is slower, 1 side is faster. Our die correction concept always go for either direct welding on the die plate or bearings, or they will reduce the die bearing elsewhere. So that's all. You correct this way. It is not a good idea to reduce the flow, faster flow. Better you increase the slower zone so that your extrudability and productivity goes higher. Roughness of the surface. What we do in our plant, we don't do any file polishing. We don't allow in fact, I don't have any die corrector also. We don't allow our dies to get polished with a diamond die. We use extrude hone, but not many people can afford or have extrude hones. At least when you have a polishing thought in your mind, instead of hand diamond polishing, just measure the roughness, say 1 micron roughness is there. You give 2 micron of rewear cut all over. Just do rewear cut. And then do soft polishing to get the blending of the bearing. Exactly, that is what I said. You should never use a file and do the polishing on a particular rough area so that the other area doesn't go slower. Length variation on multi-cavity die, that's a very big problem. Today, it is running with all cavities together in the cooler. Tomorrow, one opening slow, one opening fast. Again, the same problem. Hand polishing in one cavity, if there is more roughness, it will be polished, and then other surfaces, it will be untouched. There will be no polishing or very soft polishing. It will run fast and slow. So better if you are polishing, planning for a hard polish of a particular cavity, you do wear cut of all cavities in equity. 1 micron, 2 micron. If you think that if we polish our die life will be reduced, your die life is already reduced with this. 10 bad runs and recording your dies that my die is running since last 6 months or 6 years. How many times it delivers and how much of quantity it delivered. That is the die life. People will roughly say 25 ton. 25 ton input doesn't mean that you got an output of 22 ton. No, it may be 20, it may be 10 ton also. Many a time unloaded due to this length variation problem. White spots and pickups. Again, the relief undercut of the bearing. If there is less bearing, there will be certainly a huge deposition of aluminum oxide, and determination is very easy. Just fill the joint mark of your profile, extruded. If it is very smooth, you are sure the undercut is very less and you will have definitely oxide rub on your extruded surface during extrusion, because when the puller is pulling it, there is micro shaking, all the time micro shaking, and softer extrusion will touch or rub with a harder oxide built up. So definitely there will be some micro lines and all. And white pickups, another problem. That is because of that oxide gets stuck on the hot and soft material. And that is when we feel it, we have some granules are stuck on the surface, also on our fingers, and badly stuck. So these smaller things has to be taken care. Micro die lining, this is a serious and severe most problem in all over the world. No matter you polish it, your die is very shiny, your product is very shiny, still you find some micro lines all over the surface or somewhere. So let us understand why it happens. That is the die bearing, and we see a taper line, and we see the undercut and further taper. The first taper is to drive away the built up from the dies, billet after billet. But if the bearing edge is not little tapered, then what happens? You can feel in your office table also, if you have a sharp glass, at the edge of the glass, if you rub your hand on that, you will have a scratch on that. Similarly, extrusion is coming out and it is just landing beyond a very sharp edge. And this taper should be very carefully constructed. It has to be just a small relief on the die exit, bearing exit, maybe 0.1, 0.2 level, and no longer by 0.3, 0.4 mm. So that will avoid the, can I have a pointer? Point कर सकता है क्या? लाइन पॉइंटर है क्या? वो कैसे होगा? दीजिए, कैसे करेगा ये ना? See here, the product is running like this. This is the entry side, this is the exit side. When it is running like this, it doesn't touch the edge because there is a blending. Automatically the profile will be line free, absolutely micro line free. Do the reverse. Create this formation here and imagine the extrusion is running like this and touching here. Here it is shaking with the puller. So with this shake, there is a deposition of oxide and all. With this shake, that gives you the micro lines during extrusion. But this is backside. I have used this edge to show you the effect and started extrusion from this side. This is an imagination, but this type of edges should not be here. And most of the places we find this type of edges. Creating of this type of taper is difficult, but it is not impossible. Many people do it with electrodes. After making the die final, they will just give a 2-3 minutes sparking on the edges with a blended electrode and it can be created. Even hand file it can be created, but it depends on the skill. Using an electrode is the best solution. The moment you make this edge like this, you will not have any micro die line. Die line is one thing, micro die line is one thing, what we call extrusion line. You will never have this. Please go back to your factory and start working on this. I also do it, but I am also not able to do it 100% because everything I cannot do. But this is must. If you have die lining problem, follow this. Streak and patch mark. Try to make the blend on the die bearing with abrupt chain that we have discussed. Flow. If you want to control really the flow, you give 60% weightage on your die pockets or porthole and 40% weightage on your die bearing so that you are not stuck at you have a static pocket and dynamic bearing. Partially static, partially dynamic pocket and partially static and partially dynamic bearing blending is more scientific. Instead of 10 millimeter bearing length or 5 millimeter bearing length versus 6 millimeter or 3 millimeter bearing length bending, better you go for 3.5 millimeter bearing length and 2.5 millimeter bearing length versus larger pocket. That is much better. You can avoid stake and patch mark that way. Then we come to the billet casting area. Same. Check chemistry is there. Most of the people do that. Somebody compromise, somebody doesn't. Then metal treatment, another area of concern. We don't bother about temperature and all. We talk about degassing and all. We do research on metal degassing without knowing why the hydrogen gets uh, entrapped in molten metal. In cold metal, there is no entrapment. More you give your temperature, more hydrogen pickup is there. So basically, the role of degasser is to reduce the temperature. But people say reduction of hydrogen with our chemical, this, that. This is a wrong thing. You control your temperature. We control our temperature. That's the most important point. Not only it will reduce your melting loss, but it will give much better billet quality than your casting stability, billet casting stability. Never allow your temperature to reach beyond a permissible limit. The moment you will, people say that hydrogen content, after solidification, there is no hydrogen content. After solidification, there is porosity only. Hydrogen is not there. There will be air, if at all it is something is there. But hydrogen is not there. So you reduce the temperature and release the hydrogen. That is why people do exothermic treatment and all, either with a gas, inert gas, or with some chemical, whatever you do. But why to increase the temperature? You monitor your temperature so that your consumption of exothermic chemical or inert gases becomes less. That way, then when you are casting, you have to check all these things, bend, lock bends, inadequate cooling or high gravitation force due to high casting speed. The lock will definitely get bent. You fix it, fix the parameter. It is your plant. You have the data. You analyze, fix the parameter. Center crack, very high casting speed, rough and or bleed out log surface, excessive scale development. We don't check it. You check there. Your quality is automatically controlled. Next. Uniform molten metal temperature. Whatever is there in your furnace doesn't matter. It matters the most in your casting tundish. You design or you locate your furnace at a distance so that when it reaches into your uh, distribution tundish, it should not cross 695, 696 degree. Just that margin, your casting quality will be better. To control that, you have to control naturally the metal temperature inside the furnace. And we all know top and bottom temperature variation is there. And mostly it is around 30 degree from top to bottom. You do that over there. Then water temperature, another issue. Beginning of the casting, very good billet surface. End of the casting, the log gets bent. In extrusion, again, in extrusion there are three things: temperature, temperature, and temperature. In three areas you control your temperature, it is fine. By default, it will come all right. So there also you identify your critical areas, what you do, what you are not allowed to do, just define it. And then automatically, when in your plant, your process is known best by you, not by any expert. Experts will tell you to follow the textbook. Textbook science you follow, you will be automatically comfortable. These are the typical process flow to maintain and all. And this is available. I think this is available with the ALEMAI technical committee. You can send them a request, they will send you a copy. These are the work instruction in the various stages, what is shown in the process flow diagram. You can even take the photograph. You can request them to scroll one after another pages and you can take the photograph. I'll give you some time to take the to read and take the photograph. See here, this is a very important area. Now, how you will define 1.5% stretching? It's very easy. You have a 30 meter length of extrusion. Just place it hold it with your head and tail stalk, look at your stretcher pressure gauge, and from there you start measuring. If you want to do 1%, 300 millimeter. Allow your headstock to travel 300 millimeter. And if you can afford, you can put an encoder and a pressure sensor. It will be very easy. Why to depend on a skilled, very ultra skilled person that he knows stretching, no one know, he is on leave, that is why this has happened. No, like not like that. Then aging, we have already discussed. Most of the people, we go for elevated temperature and short cycle. It will not save you money. Surely, almost 80% or 50% aging will need or require a re-aging process. And after re-aging, we get surprised either the hardness is went down or it is not achieving further. Do not do it. Follow this. It will give you better result and it will save your reprocessing time. This is a typical case history of solar profile. Why I have selected solar profile? Because most of our members, they have been facing this problem since long. This is a typical job card, history card, or whatever you say. You should make a job card like this and collect data. Now, for your academic interest, I will say here, most of the people find black patches or some kink mark. There is a solution, and most of the Gujarat based extrusion plants who do this in a big way, they have solved it. How they have solved it, that I can share that story, but they have solved it. Or you can talk to any Gujarat extruder, they know. The trick is this area, this wall, as we discussed earlier also. This should be thicker than this wall. There should be a break, just like when a river meet in the sea confluence. This becomes wider, the color, changes of color becomes wider in the confluence. Here, if it is same, you have to have some difference here in the thickness. The problem is, we take a piece, measure, give it to a draftsman, yeah, measure and make a drawing, you make a die. All over thickness, same. No. Just be careful on these areas. And do like this. You get all datas available, run after run. Refer all datas, go back and do correction. That's all. Thank you very much. If you have any question, you can ask, or individually you can come and we can have a joint discussion here as well.
Thank you very much, Mr. Banerjee, for your very informative presentation. And do we have any questions from the floor for Mr. Banerjee? You have a question? Can we have somebody there with the mic?
No, you can call one by one also, no problem. You can call.
Hello.
Because it is very difficult to follow. Okay, please go
Hello.
ahead.
Hello, sir. We are observing pattern line in solid die.
Pardon?
Pattern line in solid die.
I didn't get what you say.
We are observing pattern line.
Crater line.
Pattern.
Pattern line, pattern.
Pattern line means?
In solid die.
Pattern line is
yes.
what?
Yes.
I've never heard about pattern line.
Okay, I guess maybe because of the noise of the AC, maybe
No, pattern
gen
line, I have not
gentlemen.
heard about pattern line.
White line, white line,
Huh?
white line,
White patches. White line.
white line. Yes.
We have, I think we have discussed in the joint, in the solid section, you are getting white lines.
Yes. Yes.
So you have to, as we already discussed, you have to take care of your bearing blend area. If a particular part, 100 millimeter wide flat portion, is traveling through at the center, it is traveling through the longer bearing. Definitely there is more stay between two bearing walls. So that is one. And white line, particularly these are called streaks, S-T-R-E-A-K. Streaks can come only due to your inadequate flow. Sometime your people correcting a flat die with the extra torque of a puller, then bearing, then the undercut. These are the major contributors. We have already discussed. So you are talking about a particular thing. We have discussed at length. You have to take care in your billet, in your die, in your extrusion temperature, everywhere. For one single reason, it cannot be. You have to identify in your plant why it is happening. From here, without looking at the nose piece, no one can say. They will give you some potential solutions, but you have to work. Basically, there is nothing to do with your die polishing. White patches are only due to oxide enriched rub. That's all. Go back to your factory, check your bearing undercut. If you are not able to check your bearing undercut, load the die, have a hand filling on the joint mark. If it is not exclusively dragged out, then you will have this problem. Tomorrow you will go back, load the die once again, extrude a few billets, and just fill the joint mark. You know what is joint mark?
Yes. Yes.
Okay. Just fill. It should be uprooted. It is not that drag. It should be really uprooted from one billet to another billet. Try to uproot that with that perfect taper and blend and smoothen. Bearing surface smoothness is a requirement, it's a basic requirement, but the smooth relief surface is equally important. It should go out with the next joint mark. Then only the next build up will be there at the bottom of that undercut. If it is built up billets after billets after billets, no way. Any patch mark, your bearing undercut is the major culprit. Bearing blending is not a constant patch mark. You will have this like a wavy mark. But one single patch mark is definitely the taper joint of your bearing. Here it is flat, here it is small, then there is a taper and there is a mount. There is no drawing board here. Whatever is suggested is checked. And in your plant, with your resources, you have to innovate that. I can give you a solution, but overnight you cannot buy that machine or buy that technology, or you cannot take me in your plant every day. So better you innovate. If you need any guidance time to time, I am available. You all know. Many people give me direct WhatsApp, they can talk, and I give them solutions. Any more questions?
Okay, sir.
Okay. I guess, gentlemen from the floor, so if you have any further queries and clarification, Mr. Banerjee will be there. We have our LMI stall as well. So we would very much would like to facilitate this discussion after the session
Yeah,
also.
no problem.
You can actually take his guidance. So any other question from the floors?
Because the next session is also there.
Yeah.
If you don't have question right now, or if you are not prepared,
Yeah.
better prepare your questionnaire. I am
And
available there in my
so
booth also, in ALEMAI
Sure.
meeting room also, wherever.
Absolutely, absolutely.
Okay.
Thank you very much, sir, for your time and for this detailed presentation. Very informative. I would request Mr. Rajesh Jainji to please come up on the stage and present a small token of thanks from our side. He's the honorable member of LMI. So, बीच में आ जाइए. Thank you very much, everybody. Now we would break for lunch, and our